Not in my wildest dreams did I think that we would last for 10 years.
There's no reason to think that they wouldn't.
Everyone has stopped guessing how long the rover is going to last.
I don't think anyone thought the mission would outlast the furniture.
Nobody could have dreamed that we'd still be here after 10 years.
Okay, might last 4 months, but not 10 years, no.
Ladies and gentlemen, we have assembled here to celebrate what should not have been. No one ever expected this to happen, that after 10 years, a Mars Exploration Rover would continue to operate on the surface of Mars almost a decade after its original 90-day mission. Good evening. I'm John Callas. I'm manager of the Mars Exploration Rover project at the Jet Propulsion Laboratory. Welcome to the California Institute of Technology. This was not in anyone's wildest imagination, to have a rover last 10 years. How could this be? We can assert unexpected wind gusts blew the dust off the solar rays to improve solar power. We can claim that operational skill permitted the rovers to survive the cold, dark winters. We can pride ourselves that we built exquisite machines. All of these are true, but does that really explain this unimagined longevity and this tremendous scientific success? Whatever the explanation tonight, we celebrate this grand accomplishment. Since the landings of Spirit and Opportunity in January of 2004, we have maintained an active, continuous presence on the surface of Mars. Now we begin the second decade of that exploration. All of this takes great leadership, so it is my great pleasure that I welcome to the stage the director of the Jet Propulsion Laboratory, Dr. Charles Elachi.
Thank you, John, and really all the credit goes to the team, to all the thousands of people who are involved in this project. It is amazing to think that it has been 10 years. I remember very clearly that night, or those 2 nights, the tension in the room, and there were many of the people here who were there, you know, Steve Squyres, Pete Theisinger, Richard Cook, David Baltimore, Gene Tattini, Fook Lee. I don't think I'll ever forget, you know, that moment when we landed the 2 rovers. And we were really doing an amazing thing, reflecting on what Teddy Roosevelt used to say, it is far better to dare mighty things even though we might fail than to live in the twilight that knows neither victory nor defeat. No question these 2 rovers were mighty things that we were attempting with them. So let me reflect a little bit on that time. You have to remember that 9 months before that, we had a very bad tragedy, you know, of Columbia, you know, and losing the astronaut on it. So there was a tremendous pressure, you know, on NASA to show that we can do things. And I can tell you, we had a lot of expectation, you know, and a lot of things were riding, you know, on this mission. And we didn't want to think, what would it mean, you know, if we don't succeed? So Spirit landed successfully. We were all excited. But then a week later, it stopped talking to us. And this really got us very nervous to try to figure out what was happening, because Opportunity was coming in, you know, 3 weeks, you know, after Spirit. And we were all concerned, is there something fundamentally wrong, you know, in the design, because the 2 were similar to each other. But with the ingenuity that the people we have on the team at JPL, they figured out the problem on Spirit before that time. We resolved it. It turned out to be not a big issue. And then we ended with Opportunity landing successfully, and what a landing it was. As you recall, we landed in Eagle Crater. First picture we took, somebody said, that looks like dinosaur bones. And in actuality, it was outcrops. For Steve Squyres, that was as important as dinosaur, you know, bones in there, because it was really exciting. For the first time, we have a lander on Mars actually seeing outcrop that you can analyze. And then after that, we analyzed what was happening in Eagle Crater. Opportunity, you know, got out and started exploring, you know, the rest of Mars. But Mars thought Opportunity was getting too cocky. So a few months after that, it got stuck into some sand dunes. So the team tried to figure out how to get out of those sand dunes, and the only simulation we can do is we thought that it's similar to the texture of powders that you use in your swimming pool filters. So of course, everybody went out, to Home Depot, and every place that you can find that powder, we bought every ounce of powder you find in the Los Angeles basin. So for a couple of weeks, many pools went not cleaned, and so a number of people were not happy about that. But again, ingenuity plays, and we were able to get the rover out of that sand dunes. So this plucky rover have survived sand dunes, bitter nights. It outlived its warranty. I wonder how many of you have cars which have survived more than 10 years without ever taking them to the shop. So it is amazing, what this rover had done. So Opportunity, along with our rovers, Pathfinder, Spirit, we shouldn't forget poor Spirit. It's sitting on Mars, wondering why are we giving all that attention to Opportunity, but Spirit did its job, 7 years, on Mars, and now we have Curiosity. And these rovers really have touched something very special in people around the world. Here at home, I heard numerous times people saying, that it really touched, this was a source of pride for our nation, a symbol of much that is best about us, our determination as a nation, our sense of adventure, and our never-end quest to know more about the universe in which we live. So Opportunity, and all the people who worked on it, from all of us at JPL, thank you and happy 10th birthday.
Thank you, Charles. Thank you, Charles. At this time, I would like to acknowledge just a few people of the many hundreds that contributed to the success of this mission. So I'll ask each to stand and hold your applause until they've all stood. Dr. David Baltimore, past president of Caltech, Dr. Charles Elachi, director of JPL, General Gene Titini, former deputy director of JPL, Dr. Fook Lee, director of the Mars program, and the 3 past project managers for the Mars Exploration Rovers, Pete Tysinger, Richard Cook, and Jim Erickson. Additionally, I would like to ask anyone else in the room who has worked on this project to also please stand, and let's acknowledge their contribution. Thank you. Thank you. Thank you all. Thank you very much. The accomplishments of these rovers are impressive. Each has established an ancient habitable environments where liquid water persisted over geologic timescales, suggesting that early Mars was much more Earth-like at a time when life first emerged on the Earth. Although time has marched forward, one rover, Opportunity, has gone backward in time, back to the earliest epoch on Mars, back to when Mars was warm and wet and habitable. This is the period to study. This is where we might find clues as to whether Mars once supported life. So like many of you, Opportunity has a bucket list of things to do and get done while we still have this magnificent, capable machine with us. Before we hear from our next speaker about some of this, let's take a quick visit with some of the scientific accomplishments of this mission.
We went into this, honestly, with big ambitions. We went in this to try to transform our understanding of Mars. And that's hard to do in 90 days, but turns out if you have 10 years, you can come pretty close. It's been a decade-long string of can we make it to the next crater?
That first 90 days in Eagle Crater was basically taking all of this information that had suggested that Mars may have been warmer and wetter earlier on to there's the rocks and there's no alternative to there have been water on the surface and near surface at the time those rocks formed. And that's a huge moment in Mars science because now you've got the rocks, you've got the proof. So the next step was to go to endurance. We saw really a rather narrow section of rocks in Eagle, And now we got a bigger section of rocks and endurance, and gave us a much richer story about how the evolution of this environment occurred.
We got to Victoria, we spent 2 years exploring it, we went down into it, came back out, walked along the edge of it, peered over the edge of the cliff.
And we could see the dune forms that existed and which way they were blowing the sediment, and a much clearer idea of the changes that occurred within the rocks when they were buried.
It took 3 years of driving. Endeavour has this rim that sticks up real high, and as soon as we pulled up to the rim of that crater, everything changed. It was like a new mission, new landing site. It's like it started all over again.
We went from what had been a dominantly acid-rich environment, and now we see minerals and materials at the surface that indicate everything that you perhaps needed to support life existed.
We have got fabulous science out ahead of us, and I don't quite really know what to expect. But from orbit, we see compelling evidence that this is a place where there are clay minerals in concentrations far greater than anything that we've seen before.
If Mars was wet, shouldn't there have been life there too? Are we an accident of the highest order, or will life form anywhere that liquid water is present? And to have the ability to answer questions of almost theological significance, are we alone in the universe, in a scientific manner by having a presence on another planet? Yeah, I can't think of any better way for our civilization to go forward.
Before our next speaker comes on stage, let's explore a mystery. You know why you never saw Clark Kent and Superman in the same room together? But have you ever wondered why you've never seen Steve Squyres and Bill Nye in the room together? Ever? Even long ago? Curious. Well, tonight maybe we could solve this mystery. It is my pleasure to introduce the principal investigator for the Mars Exploration Rovers. Please welcome the other science guy, Dr. Steve Squyres.
Oh my goodness. Thank you for that, John. It's wonderful to be here tonight. It is especially just a great pleasure to see so many people from the MER project team here. This mission has been a dream come true for me and my science team, and you're the people who made that dream come true, so thank you very much. My job for the next 15 minutes or so is to take you through kind of a summary of the greatest hits of Spirit and Opportunity scientifically right up to the current day. So let's start with the pictures. I'm going to start with our blue-collar rover, Spirit. Spirit was the hard luck vehicle at first. We targeted Spirit to a great big hole in the ground that had a dry river flowing into it. There had to have been a lake in Gusev Crater long ago, and we got there and we found just nothing but lava. The rocks were all igneous, they were all basalt. Mars faked this out. Those lake bed sediments have got to be there someplace, but they're covered with lava. So you can see from our landing site, what we did was we sprinted, rover speed, to the Columbia Hills. And the Columbia Hills are this marvelous range of hills, very, very old rocks, and that's where we spent most of the mission. Now, the next picture shows you, this was the one. This is the one we chose to climb. This is Husband Hill. It's named after Rick Husband, who was the commander of the Columbia when it went down. And as we climbed to the summit of Husband Hill, climbing a mountain as tall as the Statue of Liberty, the first ever mountaineering on Mars, we began to find totally different kinds of rocks, rocks that showed compelling evidence in their chemistry, in their mineralogy for the action of liquid water. The next picture shows, like any good mountaineer, you get to the summit, you got to take a picture. Okay, so this is a picture from the summit. This is looking to the south, and it was really not until we left the summit of Husband Hill and continued down the south side It was after we went over this mountain and down the other side that we started to really make the most important discoveries. One of those, shown in the next slide, was at this outcrop here, the one in the background, the kind of brownish rock that you see there. It's a place called Comanche. Now, one of the puzzles about Mars has always been what happened. There's this compelling evidence that it was warm and wet in the past, and yet the climate changed. It got cold, it got dry, something happened, something changed. And one thing that must have happened is that some of the atmosphere went away. We've got compelling evidence that there used to be more atmosphere, more carbon dioxide in the atmosphere. Some of it was probably lost to space, but some of it, we think, was locked up beneath the ground. And when you take carbon dioxide and you put it into rocks, what you make is carbonates, limestone basically. But nobody had ever found carbonates on Mars. This rock, this outcrop, Comanche, and its brethren, the other rocks around it, it turns out, are about 35% carbonates, iron carbonates and magnesium carbonates. And so this question of, are there massive carbonate rocks on Mars that could provide evidence for the loss of the atmosphere that could only form under watery conditions? That question was answered by Spirit. Next one. Now, this is the place that we called home plate. And after we came down off the summit of Husband Hill, we drove to home plate, and you can sort of get a sense, just looking at the trajectory that the rover followed, this was a pretty juicy spot for the rover. And in fact, if you look over there on the right-hand side where it looks like spaghetti, that's where we found the best stuff. Next slide. Now, what happened with Spirit? Spirit had a tough life. We beat on that rover really hard, and about 800 sols, 800 Martian days into the mission, this wheel right here, the right front wheel, failed. And when one of the wheels on these rovers fails, it doesn't freewheel. It doesn't just turn freely, you have to drag it. And so a rover that used to happily do 100 meters a day was now doing 5 meters a day, dragging this dead wheel through the soil. But there was a marvelous silver lining to this cloud, and that was that it dug this trench as we drove. And every so often, something terrific would pop up on the floor of this trench. We were driving one day through a little valley, and in the floor of the trench at the end of the drive, the soil popped up as white as bright snow. This caught our attention. We went over with the spectrometers, we measured the composition. This stuff is more than 90% pure silica, SiO2. This is not quartz, this is not beach sand, this is like opal, like the gemstone. It's hydrated silica. It's the stuff that forms in hot spring environments, hydrothermal systems. Okay, so this silica deposit in this valley on Mars showed us conclusively that this was a place where a hydrothermal system had existed, and in the past that would have been a habitable environment. Of course, we named this place Silica Valley. Next one, please. Now, Opportunity went to a totally different sort of landing site. Opportunity went to a landing site that was not chosen because of its landforms, no big hole in the ground, no dry river flowing into it. We chose the Opportunity site because from orbit, we saw the signature of a mineral called hematite. Hematite's an iron oxide. It's a mineral that is found in rust, and it's a mineral that often forms as a consequence of the action of liquid water. So this was like a chemical beacon visible from space saying, hey, water may once have been here. Now, you've already seen this 38-kilometer long drive that we have done, starting in Eagle Crater and then to Endurance, Victoria, all the way down to Endeavour. And we got to Endeavour and everything changed. So I'll just show you some of the best things we found along the way. The next slide, this is the dinosaur bone rock that Charles was talking about. And it's layered sedimentary rock. That's a big deal. Nobody had ever seen that on Mars before. Moreover, when we went over and we measured the composition of this stuff, it turns out that this stuff is about 40% sulfate salts. Magnesium sulfate, calcium sulfate, iron sulfate. This is the kind of stuff that you form if you have basically salty-rich water, seawater, that evaporates away. And it leaves salt deposits behind. So this was compelling evidence that there had been water beneath the ground that came to the surface and evaporated away. The other thing that we noticed right away is that the surface of Mars at this location is littered with an uncountable number of little round things. And they're 4 or 5 or 6 millimeters in diameter, and they're absolutely everywhere. The next slide shows these things that became famous. We've nicknamed them blueberries. And this is where the hematite is. These things are made of hematite. Now, in order to make that measurement, we actually needed a gathering of blueberries. We needed a place where a lot of these things had come together. We found a little bowl-shaped depression in the rock here. We called it the berry bowl. And we made a measurement of this stuff, and we found out, yeah, these things are made of nearly pure hematite. It turns out that the blueberries that are shot through this outcrop are what geologists call concretions. Concretions form typically in sedimentary rocks on Earth that are saturated with liquid water. There's some mineral dissolved in the water that wants to precipitate out, and it finds a little nucleation point, starts to precipitate, and it grows. And what you do is you make layer upon layer upon layer, sort of like the way an oyster builds a pearl, making this little hard nodule of hematite within the rock. And so this shows evidence that water just once saturated the ground at this place. Next one. Now, as you saw Matt Gollenbeck talking about in the video that we saw, we got a little taste of this stuff at Eagle Crater. But what we really wanted to do was we wanted to see what geologists call section. We wanted to see a big stack of these rocks, and we did. This is at Endurance Crater. We went down to the crater, we drove up. I remember the engineers, some of the rover drivers will remember this. We were on like a 32-degree tilt. Everybody was scared to death when we took this picture. But it shows this magnificent stack of layered rocks. And we were able to come down this hill and make one measurement after another, putting together what's called a stratigraphic section. The first stratigraphic section ever put together on another planet. And it told us a wonderful story of changes in conditions over time at this crater. Next one. Now we drove, and we drove, and we drove, and we drove. We went to Victoria Crater. Victoria was great. Victoria was this big crater, about 800 meters in diameter, and there was a cliff. It was like a 6 or 8 meter cliff all the way around it. And the rover drivers were awesome on this. You got to realize you got a bunch of rover drivers whose job it is to keep the vehicle safe along the top of this cliff. Then you got a bunch of scientists who were saying, go closer, go closer, go closer. It was fantastic. We got beautiful images. We left Victoria, and then we had this 3-year-long slog, 60 meters of sol, turn the crank, let's just go. And finally, we got to the rim of Endeavour Crater, which is where we are today. You can see the path that we followed. We spent more than a year exploring a place called Cape York. There's a wonderful place there called Matievich Hill, named after the late Jake Matievich, who played, as you all know, a tremendously important role on our project. Matievich Hill is where we made some of the most important findings of the whole mission. At Matievich Hill, we found clays. We found rich concentrations of clay minerals. And the thing about clays is that clays form, again, in watery conditions, but they speak of water with a neutral pH. Those sulfate salts that we found, okay, those sulfate salts, everybody gets excited and says water on Mars, water on Mars. It's really sulfuric acid on Mars. Okay, those sulfate salts formed under very, very acidic conditions, but the clays, like the carbonates that were found by Spirit, form under conditions of neutral pH, and those are conditions that would be much more suitable for life. We found that at Matievich Hill. The next slide, this shows something else that we saw. It's a false color image, but this shows a vein of nearly pure calcium sulfate. This thing is as wide as your thumb, it's as long as your forearm, and this is a place, it's probably gypsum. Gypsum is a mineral that precipitates from liquid water. Water flowed through a fracture in the rock here, and it just filled the fracture with this nearly pure gypsum. Nothing like this ever been seen on Mars before. And so this speaks compellingly of water, again, probably with a neutral pH coming out of the ground here. Next one. Okay, now we're getting into more recent stuff, and at this point I'm going to start sounding a little more confused because I don't quite understand what's going on. This is fairly recent. Now, I saw this, we'd seen all the blueberries before, which we knew well, and we saw this thing at a rock called Kirkwood. Again, this was close to Matievich Hill. I look at this, I say, oh, blueberry pie. Okay, this is just lots and lots of blueberries. It's not. These are not made of hematite. They're something else. And we don't know what they are yet. We're still working on this. We have a paper that's coming out in Science in next week, and it's going to talk about these things, but we don't really have a good answer for these yet. They're not blueberries. They're something new, so we call them newberries, but I don't know what they are. All right, next one. Just look at this for a minute. This just came down. This is the last 2 weeks. Sol 3528. Same outcrop, 12 days later. Now, one of the things I'd like to say is that Mars keeps throwing new things at us. All right, so here's the story. We saw this rock. It's sitting there. It looks the way it looks like it looks. It's about this big. It's white around the outside. In the middle, there's kind of a low spot that's dark red. It looks like a jelly donut. And it appeared. It just plain appeared at that spot, and we haven't driven over that spot. Now, we got two theories about how it got there. One is that we somehow flicked it with a wheel. We had driven, a meter or two away from here, and somehow maybe one of the wheels kind of managed to spit it out of the ground and have it slide to this position. That's the more likely scenario. The other is that there's a smoking hole in the ground somewhere nearby, and this is a piece of crater ejecta. Now, the crater ejecta one, I don't really believe. I think that the idea that somehow we mysteriously flicked it with the wheel is the best explanation. Anyway, we are, as we speak, situated with the rover, with its instrument deployment device, making measurements on this rock. We've taken pictures of both the donut part and the jelly part. We got our first data on the composition of the jelly yesterday, and it's like nothing we've ever seen before. It's very high in sulfur. It's very high in magnesium. It's got twice as much manganese as we've ever seen in anything on Mars. I don't know what any of this means. We're completely confused. We're having a wonderful time. Everybody in the team is arguing and fighting, and it's like Eagle Crater. It's like Eagle Crater all over again on Sol 3540, and that's the beauty of this mission. I used to have this sort of comforting notion that no matter how long the rovers lasted, at some point we would get to a stage in the mission where we could sort of sit back and fold our arms and say with a sense of self-congratulation, we did it. We're finished. Yeah, the rover's still alive, but we've learned everything about Mars that we can learn with this vehicle at this place. Mars isn't like that. Mars keeps throwing new things at us. And what I've come to realize, and this was true when we lost Spirit a few years ago, it will be true next week or a year from now or 10 years from now when we lose Opportunity, that there will be something tantalizing, something wonderful just beyond our reach that we didn't quite get to. And that's the nature of exploration. That's the way exploration has always been. And I just feel incredibly privileged and lucky to have been part of it. And again, for all my friends, all my colleagues, our MER project family, those of you who made this adventure happen, thank you so very much.
Thank you, Steve. Thank you very much, Steve. None of this has been easy. This exploration has been one of the hardest things humankind can do. In reality, these rovers were never designed for the kind of exploration they have conducted. They've crossed Great Plains, they've climbed distant hills, they've descended into deep craters, they have survived cold, dark winters and planet-circling dust storms. And yet these machines keep exploring and keep discovering. We eventually had to say goodbye to Spirit after many years of productive exploration. And we have had to say goodbye to some of our earthbound colleagues, dear friends, reminding us that we are all mortal and that our machines, very much like us, are mortal too. It takes an amazing team to deal with the challenges that these rovers have faced. And you're going to hear from a few of those team members shortly. But before that, let's take a look at some of these challenges.
Operating a rover on Mars is tricky even when the rover's working correctly. But when the rover starts having problems, it takes the ingenuity of our entire team to try and figure out how to solve it.
Engineers love boring. Boring means clear skies, no problems. The work is a little easier and the scientists get the data they want. But if you want to get an engineer excited, you throw them a curveball. Maybe some danger, maybe an anomaly.
A heater that's stuck in the on position.
The robotic arm didn't want to unstow.
The real dust storm began.
Got stuck in a dune.
An elevated current in the right front wheel.
A massive dust storm.
We had to learn to drive with broken steering.
The gears were becoming worn on one side.
We had to get very creative very quickly.
But happily, we've made it through those challenges and challenges of difficult terrain, navigating at high slopes, or having to survive for the winter by finding places that are safe for the rover to park and hibernate over the winter.
And I think to this day, you say dust storm and it strikes a little needle of terror into all of our hearts.
It's been a real fun challenge to have problems and try to work out solutions, discover what we can do and think about ways we can solve them.
Do diagnostics.
Brainstorming.
Workaround.
Workarounds. We're coming up with new workarounds to allow this hardware that is still functioning on the surface of Mars to continue to function and return excellent science to the science team.
Every day, we're shocked that it's still going. Yet, as engineers, we're going to fight really hard to make sure that it just keeps going and going and going.
The most valuable thing that we've learned from these rovers lasting so long is that if something breaks, you can find usually something that will allow you to continue the mission even though one item on the rover has stopped working.
We can even make changes on a rover that's hundreds of millions of miles away. We can make the changes on Earth, test them out here, make sure they're going to be good, and then send it up to Mars.
A piece of equipment that has not been serviced by human hands in over 10 years is still working. I don't think your car works that good.
We're going to keep pushing the rover like we meant to ever since we landed and see what we can see what's over the next hill and what's at the next crater. Stay tuned, there's more to come from Opportunity.
To help tell more of these stories, we're joined on stage by Ashley Stroop, Mike Siebert, Bill Nelson, and Heather Justice.
Thank you, John. Yes, my name is Ashley Stroop, and I am so honored and privileged to be here celebrating this 10th anniversary. We shouldn't be here. The rovers weren't supposed to last more than 3 months, and more, I shouldn't be here. When the rovers landed on Mars, I had only myself just landed at JPL a few weeks before. And nobody should let a newbie near flight hardware. Yet somehow 10 years later, here I am, a rover driver working with this incredible team, fulfilling a lifelong dream. And here we all are celebrating this anniversary and Opportunity's now decade-long and continuing mission. Now, in the video, you heard a little bit about problems and workarounds, and we're going to tell you about just a few of those. So in 2005, when Opportunity had just completed its study of Endurance Crater, we had discovered so much there that we decided to embark on a long journey to another crater named Victoria. And it was going to take us about a year, but only 3 months in, the right front steering motor failed, leaving the wheel locked, canted in just a little bit. We did a test drive, and surprisingly, we could drive almost normally, but the rover kept drifting off course and turns were really inaccurate, and we needed to find a way to work around that in order to make sure we could get Opportunity safely where we wanted her to go. So we characterized how the wheel affected all kinds of different motions, and we gradually learned to compensate My favorite was steering off course to keep us on course. And we let the rover detect errors and correct for them, and we learned to select motions that would reduce the amount of error. And a year later, we found ourselves with Opportunity parked on the rim of Victoria Crater. On the other side of Mars, in March 2006, Spirit also lost an actuator, this one the motor that controlled the right front drive motor, and suddenly our wheel was an anchor. And without mobility, Spirit was never going to survive the coming winter. So we took some tricks from Opportunity's new toolkit and tried them out. But our real revelation came when we realized what we had was that cart at the grocery store with the stuck wheel that pulls so much easier than you can push it. And we drove backwards, and so Spirit, limping backwards, dragging that anchor, successfully made it to a safe winter haven. And in the months after winter, we tried everything to learn to drive again. And some things worked, and some things didn't, and we took our time and really learned how to drive again, and we learned to pick terrains that the rover could handle. We developed some very complex sequencing techniques that allowed the rover to adapt at every step. And we also used imaging to help the rover track its very unpredictable actions. And sure enough, we completed a successful science campaign in Silicon Valley, and we continued to refine the techniques of how to drive until Spirit's mission ultimately ended in 2010. Now, Opportunity, when it was doing its Victoria Science campaign, we started to have problems with the joint on the arm that allowed the arm to move left and right. And science campaigns started taking days longer than normal, and the joint failed more and more often until we were at risk of losing the use of the arm in a configuration that was totally unusable. And of course, without the science arm, we had no mission. So the obvious workaround, steer the arm by steering the wheels. But in order to hit some of these tiny little targets, like that little white rock you saw on these steep slopes, we had to learn to drive more precisely than we ever had before. So now it was Opportunity's turn to borrow from Spirit. We took her toolkit and adapted it to the very steep slopes of the crater rim, and we successfully completed a science campaign in Victoria Crater that made wonderful discoveries that you've already heard about. Now, at the end of that campaign, we faced a very tough decision as to where to go next. There was nothing in the orbital imagery that suggested anything of scientific interest nearby, but tantalizingly, far off in the distance was this place called Endeavour Crater. Craters had been wonderful places to discover in the past, and this one just dwarfed them all. It was the perfect place to explore, except it was 12 kilometers away. And it was a tough decision. We knew there were no guarantees we would get there, and so we buckled down, we said, we made it to Husband Hill, we made it to Victoria, we can do this, we can make it there. And we made use of some new images from a Mars orbiter called the Reconnaissance Orbiter that helped us avoid some horrible, horrible dune fields that would have left us stuck forever, but that added kilometers and months to our journey. But finally, we were validated when we found this sign of the clay minerals on the Endeavour rim. This place was wet and possibly habitable, and the same signature that ultimately sent Curiosity to Gale Crater. And on August 9th, 2011, we found ourselves parked on the rim of Endeavour Crater, looking out over a brand new, or maybe I should say very ancient, Mars that was just waiting for us to explore for many years to come. And that will keep us busy for quite a while. But mechanical issues and terrain haven't been the only challenges that Mars has thrown at us, and I'm going to let Mike tell you about another story.
Hi, I'm Mike Siebert. I'm the lead flight director for Opportunity, and I have never seen Spirit or Opportunity with my own eyes. I was in college when the rovers landed on Mars. While we're here tonight to celebrate a decade of Opportunity exploring the surface of Mars, I want to take a few minutes to tell you about a time in an event that almost ended the mission by killing both rovers. It was late June 2007. It was Martian summer. The sun was high in the sky. The rovers were hard at work. Opportunity was just about to enter Victoria Crater. Spirit was hard at work in the Columbia Hills. And everything was going our way. Well, that was until the global dust storm. Slide. There's a great picture of this from orbit. It shows, you can see all the features on Mars, and then less than a month later, is just this dusty ball. On Sol 1213, the storm enveloped Opportunity. The direct sunlight reaching the rover was cut by 70% overnight. And as the skies grew darker every sol, we had to come up with a way to make sure Opportunity was going to survive this. So since the solar panels weren't putting out as much power, we decided to cut back on our activities. All science activities were canceled except for those absolutely necessary to monitor the dust storm. And that seemed to work, but the storm kept getting worse. It got so bad that Opportunity couldn't see the disk of the sun through all the dust. We now had to make hard decisions. We had to start cutting what we consider to be essential activities that keep Opportunity alive. We decided to cut back on how frequently we communicated with Opportunity. Normally, we have an uplink and a downlink every sol. We curtailed that to every third sol. And it worked. Opportunity was generating more power than she was using, but there was a side effect to this. The internal electronics were beginning to get dangerously cold at night, and Opportunity is designed to handle cold temperatures. It has survival heaters that will automatically turn on if the rover's internal electronics get too cold. The problem is these draw a lot of power, and if they turn on, the rover's battery would be depleted within a week. So we had to start thinking, how do we keep the heaters from turning on? And we realized the best way to do this, to save power, was we had to use a little bit more power. So commanding Opportunity to stay up just an extra half hour each day, we had cut it back to about an hour, so increasing it to 90 minutes was enough to keep those minimum temperatures just above the limit where those heaters would kick on, and the heaters never came on during the dust storm. At the absolute depths of the dust storm, Opportunity was getting less than 2% of the direct sunlight that it was prior to the storm. And at that point, I was really worried that we were going to lose Opportunity. I thought it was going to be the end. But the storm started dissipating, and 2 months after the storm began, the dust levels in the atmosphere had returned to normal. We all thought Opportunity was going to come out coated in dust after this storm. I mean, the entire planet had a ring of dust around it. But the wind during the storm did us a big favor. It blew more dust off the panels than settled. We had more power after the dust storm than we had going in. On the other side of the planet, Spirit didn't get hit nearly as hard. We had to curtail driving and use of the spectrometers on the robotic arm, but all in all, she kept communicating with Earth, all was well. But Spirit got a lot of fallout when the dust started to settle. She got a thick coating of dust, and after having survived her second winter that she had limped to, as Ashley mentioned, we ended up in a race against time to find a third winter location. To do so, we'd have to find a nice steep slope facing the northern sky. We needed 30 degrees northerly tilt. We were up on home plate, and we ended up driving to the north end of home plate in December 2007. But dragging that stuck wheel meant we had to come back to working 7-day-a-week operations, which we hadn't in many years, and we even had to switch back to living on Mars time. But just before Christmas, we were in position, and in January, we were on that slope. Spirit was able to survive that winter using the same techniques we had developed to get Opportunity through the dust storm. And those techniques are still being used today. The balancing of our electrical loads over multiple sols is being used on Mars right now to keep Opportunity warm and productive in her 6th Martian winter. Now, that dust storm almost killed both rovers, and the only thing that kept it from doing so was the ingenuity of the two teams. There will be another global dust storm at some point, but this time we are ready and we will get Opportunity safely through it. So not all challenges happen on Mars with the rovers. This project's on 2 planets. Earth is one of them. So I'll let Bill explain a couple of our unique challenges here on the surface of Earth.
Thank you, Mike. I'm Bill Nelson. I'm the engineering manager for MER. Let me take you back to September 2006. Like most computers, the rovers occasionally need to update their operating system. So after a year of programming and testing, and after a full month of uplinking files, it was finally time to install our update. But because this new update changed both the telemetry and the commands, it was necessary that we change the ground system in synchronism with it. Timing was also critical because Spirit was rapidly approaching Sol 1000, and only the new software could handle 4-digit sols. We have our Y2K problem too. Further, solar conjunction was looming. That meant the rovers would be on the far side of the sun and out of communication for about 2 weeks. We needed some time on the dish antennas of the Deep Space Network, but our needs conflicted with the Mars Reconnaissance Orbiter, or MRO, which was just completing its critical aerobraking phase. The 2 stereo spacecraft were launching, and they needed lots of antenna time too. And one of the 3 big 70-meter antennas was down for maintenance, which crowded all the projects onto the other antennas. Despite all this, we managed to get 2 little slivers of coordinated time to do our installation. Then, right before it was time, MRO took our Spirit uplink time. But we found a workaround. We sent our commands through the Odyssey orbiter to forward to Spirit. These would clock out automatically and be acted on by Spirit, and we would then be able to do our boot without any further problem. So we now had Spirit on autopilot. It would automatically cut over to the new operating system. So we started converting our ground data system as well. That meant that it was critical that we also command opportunity. Our window was coming up, but about a half an hour before it was time to do the commanding, the entire JPL flight network went down. This had never happened before. Suddenly, all our servers and workstations were isolated machines. We couldn't get the commands, and even if we couldn't send them to Australia, where the big antenna was. Well, we thought we were in big trouble, but then we remembered we have a backup command station, and it had intermittent connectivity with Australia. The one problem was, how do we get the commands? Well, it turned out the server and the workstation couldn't talk to each other, but both of them would use the ancient 1 1/4 inch diskette. A frantic search ensued, and we found a diskette. We copied our commands, and people literally ran from one building to the next to get this to us in time. We got the commands on the workstation. We sent them up using this very diskette. So here we are. We have a window that is shrinking. We tighten up our command margins until they squeal. We send our commands, we cross our fingers. And with just seconds to spare, Australia calls and says, the last command has been sent out the horn. So our 2 rovers are now going to cut over to the operating system. But we're not out of the woods yet. Our ground system is only half installed, and it needs the network to complete the installation. And we need that new operating system to build the next plan for opportunity. Well, we begin the planning, hoping for the best, and sure enough, just in time, the network comes back. Our ground system installation and checkout is successful. Telemetry says that both rovers have cut over to their new operating system. Finally, we're done. It's been a really exciting day on Mars. But tomorrow it'll just all be forgotten, because that's just what we do on Mars. So Heather, what's your story?
Wow, I haven't seen one of those floppy disks in a long time. Well, I'm Heather Justice. I am currently a rover driver in training. After 10 years, these rovers have returned so much more data than we were ever prepared to have to handle. So far, Spirit and Opportunity have returned over 300,000 images. Now just imagine, you take your camera on a vacation to some exotic location, and you unexpectedly find yourself there for an extra few weeks or an extra few months, and you just keep taking pictures. You keep needing to find new memory cards for your camera. How do you organize all these images? Maybe you go online and upload them to the cloud. Well, even we have collected so much data on this project that we've had to start using our own share of the cloud to keep track of it all. Now, it's a little bit surprising, of course, that these rovers, especially Opportunity, has outlasted so much of our ground tools like hard drives and computers. But hey, if we can't go to Mars to upgrade the rover hardware, the least we can do is try to keep our own tools here on Earth up to date. Of course, a challenge with trying to keep the ground data systems upgraded and running smoothly is that everything has to be constantly operational, constantly reliable. We can't just say, okay, let's hold off for a week and overhaul everything, because every sol, Opportunity is letting us know what she's up to, and we need to pay attention and make sure she's still okay, and she needs us to tell her what to do next. Every sol is precious, so we have to carefully plan out every update that we do to make sure everything's in manageable chunks. Now, we've gone through new hard drives, new computers, new software, but we've also had to cycle through new team members. Many of the brilliant engineers who really set the standard for how we operate today have moved on to new, different problems. That leaves us with the challenge of what do we do with this expertise that has moved on elsewhere? We have to bring in new people to really learn to understand these complex systems and understand why they were designed the way they were. It can take a very long time to learn some of these things. Now, I've had people come up to me pretty often and say, hey, Heather, there's this software tool that we need this update to. Can you do it by the next planning day? So I looked at this code, and there's thousands of lines of code that perhaps I've never had to look at before, written by somebody else many years ago. It's like, okay, I got a lot to learn, got to do it very quickly. But for those of us who are new members to the team, in a way, this is also a blessing. Kind of piggybacking off of a recurring theme, I never should have been on this mission. I was in high school when these rovers landed. Actually, Opportunity landed on my 16th birthday, and I never would have imagined that 10 years later, here I'd be helping to drive the coolest vehicle in our solar system. And there truly are no words to really describe how excited and how thankful I am to get to help bring my perspective in on these ongoing challenges and to really help out with such an incredible adventure and such an incredible team.
So in conclusion, I just want to quickly answer the three questions that I, and I imagine all of the rest of us, always get asked. How do you keep a rover going on Mars for so long? Well, we have this amazing, dedicated, talented team of people who can use every tool at our disposal to its fullest potential and then invent completely new ways of using those tools that nobody ever imagined. And we are just a small representation of that team here today. So how long will the rovers last? Well, we like to say, don't bet against the rovers. It's a good way to lose money. And last, what does it take to work on the Mars rovers? People expect me to talk about a skill set or a college major, but that's not the answer. My answer is it takes equal parts of passion, paranoia, and imagination. Thank you.
Thank you very much, Ashley, Mike, Bill, and Heather. In addition to great scientific discoveries, these rovers have also given us a great intangible, something else, something special. We've come to love these rovers, all of us. We have invested them with human qualities. They are accomplished, intelligent, intrepid, playful, and of course, so darn cute. They carry to this alien world our dreams, our hopes, and our highest aspirations. They carry us along with to these great unknown places. So over this past decade, our species has gone to work on Mars. So in addition to being Earthlings, we have now become Martians too, dual citizens, if you will. Mars is now our neighborhood, our backyard, and with these rovers, a generation has now grown up on Mars, and some have grown up to work on Mars. For people all over the world, the rover's story is their story. Before I introduce the next speaker, here are some of the ways these rovers have become part of our popular culture.
And one note from space tonight, evidence that Earthlings are indeed invading Mars.
Angry red planet, bringer of war, manufacturer of Skittles. Mars conjures up a forbidding sense of danger and power. So when NASA's robotic probe, the Spirit, successfully touched down on Mars this weekend, it prompted NASA engineers to go crazy. The roof is on fire. Yeah! And someone's putting the moves on that cute topographical data analyst and on-site telemetry. You know, to scientists, Mars is like mistletoe.
Okay, everyone, focus. Prepare to enter the atmosphere. Let's get this thing onto the ground. Camera. Now, if there is life, the Dutch will find it. Wait. What is he doing? What is that?
Now we wait.
NASA's rover Opportunity has wowed scientists on Earth repeatedly, not least by lasting 10 times longer than they'd ever imagined.
Tonight, I'll ask NASA's Steve Squyres what these Mars rovers will do to stop Ziggy Stardust and his spiders.
Squyres and everyone at NASA were greatly relieved when they landed safely on the Red Planet 4 years ago.
They are the Energizer Bunnies of outer space. The twin Mars rovers, Spirit and Opportunity, keep going and going and going.
Holy smokes, I'm just blown away by this.
This is one of the most incredible motion pictures ever produced, and it's from Mars.
Next month will mark the 5th anniversary of the rovers landing on the Red Planet.
There's never a wrong time to enjoy an ice cold Diet Pepsi. The warranty expired in 2004. One rover is down, but the other refuses to die and continues to send back stunning images and astonishing new data. 10 years on Mars and counting.
It is my great delight to welcome to the stage the Chief Executive Officer of the Planetary Society, Bill Nye, the Science Guy.
Thank you, John. Thank you, man. Great to see you. Thank you. Greetings, everyone. Greetings. The Spirit and Opportunity rovers, about $450 million each. We're into the missions now about $900. They're only this big. Let me tell you something. They're not even locked. Anybody up there could just walk up to them. You'd think we would have thought of that, but I guess it's been okay. Anyway, it's great to see you all. It is an honor to be here. This is one of the many pictures that fills me with joy. The thing that always strikes me that's so strange about Mars is it's a place. I mean, if you were dressed properly, you could go there and have a picnic. I mean, it's cold. You want to dress warmly. It's very cold. And, it's a camping trip. You want to take something to eat, some food, water. I guess would that be Tang? And and it's very important. You have to take something to breathe, because they don't have anything for us to breathe, and that's only funny if you're scientifically literate. And we are living at this extraordinary time, very exciting for me, where science is becoming cool. It's cool to be into science. You don't believe me? Check this out. Not only, thank you. Not only is the Big Bang Theory, no matter what you think of it, the Big Bang Theory is not only the most popular sitcom, it's the most popular show on television. And people, I look like nobody, all right? I'm standing this close to Bob Newhart. Trying to out deadpan Bob Newhart. It's not going to happen. But people watch the show because, in its way, it celebrates what you all do. It celebrates this process of discovery. Now, I got involved with the Spirit and Opportunity Rovers because of Dr. Jim Bell, Dr. Jim Bell, who approached me on a flight to Ithaca, New York. If you've never been to Ithaca, you just don't go there. It's like way off. It's off the beaten path. And through the success of the old show, the Science Guy show, he invited me to this meeting about Mars. And they had these drawings laid out and so on. And I was standing there thinking, why are we doing this? Why are we exploring Mars? What's the deal? Well, my friends, there are two questions that trouble us all, deep within us. And if you meet somebody who says he or she has never asked these two questions, they're lying. I'm sorry. The first one is, excuse me, yeah, where did we come from? Now, this is a striking picture that was just included in a collection at the Library of Congress. And it's a picture of Saturn. You may recognize it. And it's also a picture of the Earth. The picture of the Earth, it's that little dot. Where did we come from? And then the second question we all ask is, are we alone? If you meet people who have never asked those questions, of course, they have, I guarantee it. It's like meeting somebody who's, no, they've asked these questions. And so to this end, the Spirit and Opportunity Rovers are actually seeking answers to these questions. If we were to discover evidence of life on Mars, or stranger still, something still alive on Mars, it would, dare I say it, change the world. No one would ever think about our place in the cosmos, our place in space, the same way. And everybody here who participates in society by, let's say, paying taxes, even if you buy something and you pay a sales tax, you have contributed to this. These missions, seeking answers to these questions, bring out the best in us. So I got invited to this meeting, and they had this scheme. I don't know if you remember this, but on the Viking missions back in the disco era, in the 1970s, for a few days, the color of the rocks were in question because they had gotten the color of everything off a little bit. They sent the calibration done here on Earth to Mars, and it took a couple days or a day and a half for people to realize that they hadn't quite gotten it right. So the premise was, we'll send something to Mars to cast a shadow, and we'll look at the shadow. And if you've never done this, I strongly encourage you to do this. Go outside on a sunny day. I think we have one planned tomorrow. And make, for those of you watching on the web, we are in California. Sorry, we have a sunny day planned a lot here. Make a shadow on something white. Like my shirt is good. You can use your finger or a pen or your friend's head, whatever you have. And if you look at the shadow, you'll see here in this room that the shadow is gray, but if you look at this shadow on my shirt, you can see it's also quite yellow, and that's from these lights here in the theater. On Earth, the shadow is just a little bit light blue, ever so slightly light blue. Well, on Mars, it was expected to be yet a different color. So we had this thing casting a shadow on these circles of known value, of known gray. And I was in this meeting, and I thought, there's a lot of things to cast a shadow here. We've got antennas and panoramic camera arms. We've got high-gain antennas. We've got little squib things. No, we're going to send this thing to Mars. And so, can I have the next slide? So I'm like, you guys, this is a fantastic opportunity. My father had the misfortune to spend almost 4 years in prisoner of war camp. If you get a chance to do that, I'd avoid it. Don't do that. But he had no electricity for almost 4 years, and he became fascinated with sundials. And I grew up with all this sundial stuff. So they're going to send this metal post to Mars to cast a shadow. I'm jumping out of my chair, Dr. Squyres. We've got to make this photometric calibration target into a sundial. And Dr. Squyres and Dr. Bell are looking at me. Dude, really? This is the space program, we don't use. Bill, you're wearing a watch. No, you guys, it'll be cool. It'll be like those guys who speak Klingon. Except it'll be real. All right? We can reckon time on another world. So after 3 days or so, Dr. Steve said, okay. So my friends, the Spirit and Opportunity rovers carry a sundial right there. It's only this big, and it has a post or gnomon, which is from the Greek word to guide, and even made of plastic. In this room, it casts a shadow. Coincidence? Perhaps. But my friends, perhaps you have done this. You're in a boat. Maybe you're walking across a bridge, and there's just something comes over you. You reach into your pocket, and you take out your keys, and you go, I sure hope I don't throw these over the bridge. Or maybe you've done it when there's something in the trunk of your car that has your keys in it, your gym bag or something, and then you just slam the trunk on it. Well, let me tell you something. When you have something in your hand that's now on Mars, it's a little different. All right, if it throw it in the lake, you could just hire the right dive team and go get it. If you throw it off a bridge, you figure it's at the bottom down there someplace. You'll drive down or walk down and get it. But when it's on Mars, it's like, it's gone. So we sent these to Mars. I guess we need one more. And indeed, I hope this doesn't shock you, they cast shadows. And I'm pretty sure, even in this light, maybe most especially in this light, if you look there in the lower right where the shadow is being cast by the gnomon, you can see that the shadow is orange. We didn't have a word for this in English, so I made it up. It's orange-descence. And so on the Earth with the blue sky, it's cirrulescence. See, there is a word viridescence if you play crossword puzzles, but now we have orange-descence. And the little red dot would be Mars in its orbit, and the blue dot would be the Earth in its orbit. And if my father were here, he would remind us all that sundials should have a motto. They should give you something to think about. And the guy who really pursued this was Woody Sullivan, who's on the MER team. And he said, we've got to have a motto. And Lou Friedman, who's my predecessor at the Planetary Society, came up with the fantastic motto. If you look closely down here, it's a little below the frame. It says, 2 worlds, 1 sun. Shadows on Mars are cast by light from the same life-giving star as shadows on Earth. If I may, how cool is that? And they're orange. And so, thank you. So we do, Dr. Bell, Dr. Squyres, continually sort out the contribution of the orange sky to the color of the rocks, because my father, by the way, is quite the rock hound, and there's a lot of geologists here, right? Yeah, right on, yeah. They're a little embarrassed. They're a little embarrassed because they all walk around like this. Just hoping to see something cool. And you go to their house, their garage, or whatever, it's just rocks. It's just all these rocks. And they explain, oh, this one's different. No, really. No, really, this one. But of course, that's true. So anyway, now we can get the colors right, and it's an exciting, wonderful thing. We have the next slide. So I did the vibration analysis on this gnomon, and it's fine. I mean, it's indestructible. You tow a truck with it. But somebody sent me this picture, and whoever did it, he's probably in this room or she's in this room. You got me, all right? I mean, there was a full sort of comedy beat, like, and then I realized it was April 1st. Oh, these kids, these software kids with their Photoshops and their, it was kooky. So, thank you, whoever did that. I won't say you ruined my day, but you probably shortened my life, just did that much. Sorry, I couldn't hear. Was it a funny heckle? I couldn't quite make it up. You're welcome. Oh, thank you. There he is. Is that Doug? Yeah, thank you. Brilliant. Just next time, it's threaded. There's a hole. But that's all right. You got me. So, even this little thing means so much to me. This little thing, this little object, which casts a shadow and highly reliable. Now, everything else, as far as or most of the significant instruments on the Spirit rover are no longer working. But I have a very strong feeling that the Mars dial is still operational. And if everything had gone wrong, the plan was to use the shadow to determine true south. Yeah, that was going to be in case everything else messed up. Because if you're on a round planet, what I brought to the party, when you're near the equator, you don't want to put a triangle sticking up, like a sundial that you might see around here. Because sometimes the sun's to the south of you and sometimes it's to the north of you. This is my father and this stuff. And so if you go to Hawaii or someplace, you'll see rectangles or just a stick. In English usage, is a noon pole. That's what my dad used to use, apparently. And then the other thing was, it's on a rover, so we don't want hour lines. I mean, you move it all and everything would have to change. So we did that electronically. That was, anyway, for several weeks we computed Mars hours for you Klingons. It worked fine. You can try it. So along this line, I had, through some remarkable clerical error, I had Carl Sagan for astronomy. And then I joined the Planetary Society when he started it in 1980, along with Lou Friedman, who's here, I'm sure, and Bruce Murray, who died recently. And then I've been a member ever since. And then a couple, I guess it'd be 3 years ago, I guess there was wine or something. I left the room, and now I'm the CEO. So it is an honor to carry this legacy forward. And I appreciate, I know some of you, many of you are members, and I appreciate that. So Spirit and Opportunity rovers are something that was done largely here at JPL. But the thing about space exploration, it includes all of us around the world. And if we look at Mars from orbit, we can see something that's going to affect everybody here, I predict, certainly in the next century, but maybe next week, maybe tonight. There's a crater on Mars. There's another crater. Oh, there's one. Wow, there's a lot of craters. Thousands of craters in this one view. When I was in astronomy class with Carl Sagan, he made a big deal out of the Chelyabinsk, made a big deal out of the Tunguska event. Kind of the next slide, sorry. The Tunguska event, which was in Siberia in 1908, as reckoned on the modern calendar on the 30th of June. And this is a case where an asteroid or an impactor hit the Earth's atmosphere so hard. You know the story, they say if you jump off the Golden Gate Bridge, you're going to hit the water so hard it'll act like concrete. Well, if you're a meteor, if you're an impactor hitting toward the Earth and you hit the atmosphere, it's the same deal. So apparently this thing just exploded over Siberia, knocked down trees for thousands of kilometers. And nobody, it was so remote, how remote was it? Nobody went up there to take a picture of it for a year. But, and Carl Sagan made a big deal about this. You know, this could happen again. We should be concerned about this. But as you may know, the last century or so, people went along, oh, that's not very likely. Don't worry about it. What could happen? What? What's the worst that could happen? And then last February, as you know, we got hit again in Russia. If you're a meteoroid, an asteroid, and you're coming toward the Earth from the north, it's very likely you'll hit Russia. So, no, it used to be 11 time zones. They changed a couple, but it's almost half of the northern hemisphere. The other thing is Canada, and we can all. No, it's there. They're not moving it, and so it's. This is something that could happen very easily. And I am proud to say that the Planetary Society has identified, next one, asteroid 2012 DA14, which kind of got punked by Chelyabinsk. It happened in the same day, the same 24-hour period. This asteroid passed between the Earth and our geosynchronous satellites. So my friends, space exploration is important to everyone on Earth. If we drop this ball, it's a good chance we will go the way of the ancient dinosaurs. I remember very well Mrs. McGonigal, my second grade teacher, telling us, she was reading from a book, that the reason the ancient dinosaurs died was because they had small brains. So then all the mammals took their food and the dinosaurs died. And even, I mean, I gotta tell you, even Ms. McGonigal was like, no, I'm just reading, okay? I mean, I'm a Tyrannosaurus, you're a rabbit. I mean, we're done, all right? That's it. Hey, Rex, you might want to try some salt. Here's an outcropping, some gypsum, yeah. So, I lived through the discovery of the most reasonable theory for the demise of the ancient dinosaurs. And that doesn't really appeal to me. I don't want to go that route. And so I know here at JPL we're working hard on what may be a scheme to deflect one, but it's going to include everybody in the whole world. And if you don't believe me, consider this. I don't know how many of you are aware, but the Chinese Space Agency has a rover on the moon, driving around, doing science, and especially advancing their technology for space exploration. And it was President Johnson who remarked in 64, that you cannot be first in the world and be the second in space. So there's going to be an exciting time ahead. It's going to be an exciting time for all humankind. And the Spirit and Opportunity rovers are a symbol of what we can do. What's remarkable about space exploration, I claim, is it brings out the best in us. It's when we try to solve problems that have never been solved before. It's when we try to explore spaces, we explore areas that have never been explored before. This is what it brings humankind together in a way that nothing else does. It advances technologies like nothing else. It leads to innovations like nothing else. And this is why the space program is so important to the United States, and really space programs to every country in the world. Can we get the next one? So this is the Curiosity rover. Actually, it's a picture of it. It's not here. It's on Mars. And just the budget of this program is so tight. How tight was it? Took the flight spare out of Dr. Bell's drawer, screwed it on the back, and there it is. The third Mars dial is on Mars. Now, I am so excited about these things for another reason to this day. Every single day, I am filled with joy about these things because this is the first time, these rovers are the first time since the Viking missions, since the Voyager missions in the 1970s, that we sent a message to the future. We put something on there for somebody else coming behind us. Around the edge of each Mars dial, very small letters, it says, we launched these rovers in 2003, they arrived here in 2004, we built these instruments to study the Martian environment, to learn about Mars's past, prepare for our future. And then the last of the 4 panels, it says, to those who visit here, we wish a safe journey and the joy of discovery. And that, my friends, is the essence of this business. That's why we're here, is the joy of discovery, the joy of knowing. And the idea that somebody's going to go up there and have a look at it is fantastic. It's inherently optimistic. It's for all humankind. It is astonishing. And by my recollection, the guy who coined that phrase, joy of discovery, is Dr. Steve Squyres. And I am honored to be here with you, sir. It's fantastic. So one more slide. This is not a picture of Mars. This is part of the space program where we got a camera out beyond the orbit of Saturn and took a picture. And I imagine many, many people in this room are familiar with this. Can you click it once more? It's not just a picture of Saturn, it's a picture of the Earth. And if we could go up there, just 100,000 kilometers, take the same picture, that's it. That's the Earth. That's the whole thing. This little dot in the middle of nowhere. My 3rd grade teacher, Mrs. Cochran, said there are more stars in the sky than grains of sand on the beach. And at that time, I wouldn't have expressed it this way in 3rd grade, but I remember thinking, Mrs. Cochran, are you high? That's impossible. Have you ever been to a beach, Mrs. There's like sand. There's just sand everywhere you look, and the tide goes out and there's more sand. You look behind you, there's sand. I grew up, we'd go to the beach in Delaware. There's 1,000 nautical miles in each direction of sand. You know, it's before Snooki. It's just sand, sand, sand. And I remember thinking, you're telling me there's more stars than all of that. I'm this little kid. I just was thinking I'm no different from a grain of sand. I'm just a speck with these other specks on the beach. And the Earth, when you look at it like this, is just another speck orbiting the sun, which is another speck. I mean, it's a completely unremarkable star. There's billions of suns, billions of galaxies full of suns. I am a speck on a speck, orbiting a speck, with a bunch of other specks in the middle of specklessness. I am nothing. But my friends, with our brains, which are only this big, in the case of my old boss, of course, quite a bit smaller. But with your brain, you can imagine all of that. With our brain, we can know our place among the stars. We can know our place in space. And with our brains, we can explore these other worlds and answer these 2 deep questions. Where did we come from? And are we alone? That is the essence of this. That is, my friends, the joy of discovery. It's an honor to be part of it. Thank you all. Thank you. Thank you. Thank you, John.
Thank you, Bill. Thank you very much, Bill. Before the last remarks of the evening, let's thank all of our speakers tonight one more time. Dr. Charles Elachi, Dr. Steve Squyres, Ashley Stroop, Mike Siebert, Bill Nelson, Heather Justice, and of course, Bill Nye. 10 years ago, our species landed on an alien world tasked with a 90-day mission of exploration. Tonight, we observe a great accomplishment in that mission, the achievement of 10 years of continuous operation and exploration of the surface of Mars, and of course, wonder how long will this remarkable mission continue. But in a larger sense, no one can fully comprehend all that these roving missions have accomplished. These two rovers will forever change our view of our solar system and ourselves. It is rather for us to continue this great task, that discovery and exploration of our universe shall advance far beyond the Earth. Thank you very much, and good night.